Okay, looks like I'm streaming now finally. Thought I was streaming earlier, but I wasn't. So I need to give a rehash of what's going on here. Okay, so really quickly, what I am doing is I am retrofitting one of Crayon King's expansion boards, which is actually designed for his RGB solution, right here. His board design setup is so that you can take his RGB board and sandwich it on top of this expansion board, and doing so provides you with easier to solder onto input pads and output pads, specifically for your RGB output and for a new composite and S video outputs. But since I already have an RGB board in place, specifically I've got Yannick's 1.2 board here, what I'm going to do instead, or what I'm going to try to do, is to actually retrofit so that the RGB outputs from Yannick's board will go into this new expansion board and provide me with a new composite and S video output using Yannick's RGB signals. In theory, this should work. It is listed on Crayon King's website, or not his website, but on his eBay listings, that this should be possible. So that's what we're going to do. So what have I done in the meantime? Well, I originally had one of the old RetroFixes composite boards in place. In fact, it used to install back under in this section over here. So I've removed that because I will no longer be using that, but I might use it for another future project, or maybe another client will want it for just composite and not want to spend all the big bucks for the rest of the RGB setup. The other thing I've done is I've gone ahead and I've got a 5-volt wire right here, soldered up directly to the 5-volt input on the expansion board. I could have just soldered it from the 5-volt coming off the output of Yannick's board, which would have been just basically straight across here, actually from this point to here. But I want to try to not have to mess with this as much as possible. I'm already going to have to as it is, just for the RGB and sync lines. So I would rather not have to touch it. And besides, I'd prefer to have the ground, to have its own separate ground and 5-volt wires. So the other thing I have is here's a ground wire here that all I got to do is just loop it down kind of like this, and I'm just going to just solder it down to there. And the reason for that is because I already had a ground wire attached here originally from the old composite board. So this is kind of an experiment. Again, in theory, Crayon King's eBay listing says it should work with other RGB solutions, but of course he cannot provide support for that. So as far as I know, this is the first time trying to incorporate this and make this work and see if it does work from Yannick's board. So there's one other thing I'm going to have to attach for all this to work, and that is that it will need an external clock signal. So I'll have to get an additional piece of wire here to solder off of the clock pad here and run it over to where pin 15 is on the color chip. And I think I've looked at this before, and I believe I have found, I'll need to go get my meter, it's downstairs, which is not good because you should always have your meter present. Always, always, always. Let's see, would it be better if I came around that? I don't know. Also, if I want to avoid any issues, I could just solder it straight to this corner. That's probably what I'll go ahead and just do. I'll just solder it to this corner here. So let me increase the temperature of my iron a little bit. And I will rough up this area just a little bit. There. Put some solder on it. And because I don't know if this is going to work the way I need it to 100% is another reason why I'm not just attaching it directly off of Yannick's RGB board. In case something goes wrong, I'd rather try to isolate this as much as possible. It's already bad enough it has to use the same RGB outputs from Yannick's board in order to operate, so... Go. Looks good. Just get this kind of out of the way here a little bit. Okay, here we go. All right. So I've got 5 volts, I got that. Now I got to put in my input lines from the RGB. Also, I need to run another audio wire. Because I do have separate RCA jacks that I use for my composite and hopefully a new S-Video. If this works, I will have to install an S-Video jack onto the case, which I do not have one currently because there was not really an S-Video solution in the past. So for now, I'll be able to connect it up to the composite, make sure that works and looks okay, and then I will also be able to temporarily test the S-Video as well. I can do that. All right, so now I just need, what am I going to need? 4 more wires, 4 more wires. I'll just use these wires. Not color-coded, but it'll be okay. It'll be fine. All right, so I've got red, green. Okay, so what I'll do is I'll use my purple on this. Really shouldn't because I already use the purple wire on the input side for 5 volts. But that's okay. I don't think anybody else will be working inside of this thing besides me. But I'm doing this so that I can attach these where they need to go. And of course they're not in the right order. You know what? If I have to separate these out anyway, I might as well just use some red wire. And it does look like I have to separate them out. So at least the blue and green, because they'll attach from here over to here. And then I also need to get the red. What I could do is use these 2 wires. I've got these 2 wires sitting here. Yeah, they're completely different colors, but they would work all right. Okay, which one is the sync? Oh, that's interesting. It looks like I used purple for the original sync wire on Yannick's board, which is right there next to the red. Yep. So that's sync right there. Okay, so we need to get the blue and the green to fold over and attach to the blue and the green there. And then I'm going to need to get red and sync, which I'll use the gray and white. That will fold over pretty nicely like that. Okay. Won't be the most elegant looking, but it should be okay. So let's go ahead and separate these 2 really quick. Strip them really quick. All right. As these will be just soldered onto the tops. Although, really, only the sync line needs to be soldered to the top of anything because Yannick designed his board so that the output resistors here, the 75 ohm output resistors, if things were too dark, then instead of having to remove them, he actually put vias behind and in front of them so that you could just use jumper wires to bypass them. But that also means that here is my RGB outputs on these vias that are directly attached to these pins. So I could just solder directly to those and not have to worry about my wiring, the current RGB, falling through. Only the sync wire would be a potential issue in this regard. All right, let's get that. Wait, this is still really too hot. Let's turn that down. Okay. I do not need the wires to be that long, so I will trim those up. So yeah, what I can do is I can just solder these right onto those vias. And what I will probably do, excuse me, okay. Now that I've done that, let's flip this around. Okay. Takes care of my blue and green. And then I'm going to use these two wires to provide my red and sync. So the red will attach from there, the sync will attach to a different point. Strip some of this back a little bit. I'll actually do these individually instead of using my strippers. Okay, so that goes there like that. Sync wire needs to be trimmed up. Not by much, but a little bit. All right. Now this. Okay. Okay, that's kind of what I was afraid of. It looks like the original sync wire may have popped itself down a little bit. See it there. See if I'm able to grab it. Pull it back up through there. Okay. Alrighty. That takes care of red input and sync. We'll go to here. Should be able to cut that right about there. Okay. Now we'll go ahead and get all these input leads attached. And I always find the easiest way to do that. Well, actually, it might sit in here. Okay. Nope. That's what I thought. They're going to fall out on me. So okay. That should take care of the power, ground, and the necessary inputs. Now, to put on some temporary outputs to see if this even works. Because this may be all for naught. And the only outputs that I am concerned with using is just the ground, composite, video, possibly for now. Not sure. I do need to run another wire from the audio. Forgot about that. And again, my original wire colors were green, yellow, and orange. Okay. Perfect. There's a section of unused wire right there. There's some green, yellow, and orange. Exactly in the same order I need them to be. I keep almost all the lengths of wire that I don't use. If they're released within about 6 inches of length or so like this, I will pretty much always keep them because I might need them for short little runs, kind of like how I needed, just a little bit of wire for just across here. So yeah. Okay, so for this I will need ground, video, and then the orange was audio. So in this particular case, if I'm going to, let's see, I might actually have to run these back in this direction. Yeah, probably. So what we're going to do here, well, no, that won't work very well either. Well, it's going to be a really tight fit, really tight squeeze, but we'll make it work. So for now, what I think I will probably do is, let's see, I need this audio wire, which will be my orange, to connect from here, whereas the ground and video just need to run to there. So what we will do is cut right there, there. Won't need those anymore. We'll pretty much just eyeball strip these to roughly the same length. They're just soldering onto a pad, so don't need to be that long. Eyeballed that pretty good. Oh yes, I still have to attach the clock signal. Can't forget the clock signal. I almost did. Oh, Crayon King. Sync needs to be kind of done a certain way. So assuming a 5-volt peak-to-peak sync signal, you want, sorry, I'm just now seeing this, and because of how I've got my laptop webcam angled the way it is, it's hard for me to read the chat, but let me see this. Okay, so signal, you want a 600-ish ohm resistor to make it about what that kit needs. Since you aren't using the RGB out of the kit, then the resistance isn't too important as long as it lowers the sync input, the op amp of the IAMP board, to around 2.2 volts peak to peak, down to around 1.1 volt peak to peak. Well, I'm not sure yet. Guess we'll find out. What I can do before I plug it into anything directly is I would need to, I could hook my meter up to see what we're getting off of these outputs. I do find it strange though with Yannick's board that I actually don't have to remove his 75 ohm resistors. I mean, I can. It results in a very bright image. I almost think it's too bright. But it could also be because of the palette he's using. I actually don't remove his resistors, even on my Genesis wiring setup. But again, if you're watching what I've been doing, and I guess you have been, I am using the outputs from his board and his sync to the inputs on the expansion board. But you're already paying attention to that. So I don't honestly know the answer right offhand to what is coming off of Yannick's board. I've never really had a reason to question it before. And I can't test his new version boards because he's no longer going to be, he's basically worked out a deal with Console 5 to exclusively sell his new version boards. So I can't see, or I can't test what that's going to be like until those boards are in Console 5's hands and available for sale. And they are not yet, currently. My understanding is they have gone out for production, so Console 5 should get them soon-ish. But I'm not sure when exactly they will get them. So and this is experimentation anyway, just to see if this is an option. The reality is, if anyone wants an RGB upgrade in an Intellivision right now, the only one I can offer them is actually your board. Okay, I'll go look at his schematic. Oh, you have his schematic? See, I don't even have his schematic. But if you've got his schematic, then there you go. I don't have his schematic on his board at all. Okay. All right. Flip this around the other way. Make it a little easier to solder onto the pads. All right. We're going to need the ground. Probably have to increase the heat. Yep, video attached. The ground is not cooperating. Let's get some more. Okay, there we go. I bumped the heat up just a tad. All right. Now again, I'm only wiring up these wires the way I am because I already have connectors in place. Because I've already got RCA jacks installed from the previous composite I had on here. What I'll do for S-Video is I'll probably just solder on a couple of Yep. I'll probably just solder on a couple of these wires here, or these pin headers for temporary connections onto the pads, and then use my harness I have for testing that. And then the video is the way that it is because it needs to, oh darn, doesn't look like I quite did it far enough, but that's okay. Luckily the audio is the very first solder point off of Yannick's board on his outputs. His version 2 board has these labeled now, because that was really my main criticism with his current version board, was that he didn't have any output labels. No markers of any kind, no numbers or anything. It was just, here's the vias. So that's why I made my little chart when I did my install, so that people would be able to see that. Okay, so not ideal, but that's okay. Let's see. All right, so what I'm going to do on this, just as a quick test, is I will strip all three of these and I will just put this on there, just solder this on really quick for testing. Let's strip this back. Not enough. There we go. Let's see here. Come back with anything? Okay, what do we got here? I'll go look through. Okay, just checked. Okay, hold on. Just checked. You can actually use his sink as is. Yeah, no need to do anything. Okay. I was assuming that, but I'm glad you confirmed that. And that's handy. I guess we'll find out here momentarily when I at least connect up composite as an initial test. And if this works, this will be good, because I'm more than happy to offer this as another option for my clients that would like to go or possibly have an additional composite in S-Video added, and if they already have Yannick's RGB in place. I have physically installed Yannick's RGB board in about half a dozen consoles, maybe more, well, probably a little more than that. I originally had 10 boards. And I installed one in another SVA that I sold. And I believe I've sold 2 others separately by themselves to people that wanted to install them into their Intellivisions. So I think that just means there's only 6 others that I've installed outside of this, because I only had 10 boards initially, mainly for testing, plus the one you see here, of course. Although I do theoretically have one of Yannick's older boards, his first version 1.0 board. It does work, but it's not. It doesn't work with OSSC, and it does have some video dropouts still on games like Diner and stuff like that. So I'm really not a fan of this new roll of solder. Too bad I got a full pound of this I got to go through. Number one, it's a little thicker than I normally use. The stuff I had before was thinner. And this has rosin core flux in it, but it's got no clean. And it seems to get sticky. It's just, I don't know, it's just different. Stuff I had before was your standard rosin core, but it's made by the same company. It's MG Chemical. Okay, let's get those little bits off of there. And get this, let's see, how do I have this wired up? That currently, not that it really matters, as long as I kept the pins in order, and I did. Okay, green, orange, yellow, or green, yellow, orange, rather. Okay. So I can really attach this however I want. Again, this is strictly temporary, just to see if this is even gonna, just to see if this is gonna work. What else we got? Oh, okay. You haven't said anything different. Kevin, I imagine you are also curious to see how this looks, and that's why you're watching diligently. Okay, let's see. I'm going to need to give myself a little bit of extra assistance here. Let me get my quad arms out. Take that off for a second. All right. So I got 2 different angles going on, so you can kind of see what I'm trying to do here. All right, so I need to get that. Set these both down out of the way real quick, as much as I can. Okay. Now, luckily, I've soldered to this thing before, so it should be fairly easy to do this. Yep. Okay, the yellow definitely attached itself. That's good. Or did it? Nope. It's not on there very good. Let's prove it. Nope. Broke free on me. Darn it. All right, maybe I'll use, instead of these 90-degree ones, I will use some straights. You are a little curious. I've been using this expansion circuit in my personal console for many years. Cool. Well, considering that the results I get between Yannick's board and yours are very similar as far as the compatibility goes, I don't think there's going to be anything to worry about here. I think it'll probably provide us with very similar results across the board, really. All right, let's tack these up with some solder on the ends of them. Okay. It's way more than I need, but that's okay. Let's go ahead and try to get these as flat as I can. Tighten this up. I'm just going to have to hold these manually. Okay, there's the green. The yellow. There's my audio. Now, to prevent this from ripping, it will go like that. Okay, that's holding good. There we are. Nice. I normally have these all the way. I usually have these up here all the time, my quad arms, but because they kind of block the view in the camera, I took them off the bench for today. Okay, so not the best soldering job, but it will work for what we're testing here. Does this actually fit around that? No, that's okay. And the reality is I might actually leave it like this. If this works, I'll probably just go ahead and use this wire as it is. Okay, it's a little longer than I like, but that's okay. All right, so let's try putting it together. Let's see what happens. Oh, I still got to get the clock. Are you yelling at me about that? Okay, you're not, but I still have to solder the external or the clock line. I think, gosh, I really should have brought my meter up here. I was using it for another purpose downstairs, so I don't have it up here right now. I'll need to go get it. I'm fairly confident that there is a via or a pad over here in this section that I can actually get clock from. And I know this because I've tested it before, not only by testing my clock signal with my frequency counter. I don't know if you'll be able to see it. No, you can't because it's, let me raise this up a little bit. Scooch this over. Okay, so that's obviously one of my LED lamps. So here is my hot air station, and here's my actual Hacko 936 station down here, my iron and its holder. This is my bench power supply, my old BK Precision model 1730. So it's supposed to provide 30 volts output at up to 3 amps. The reality is, it could just be because it's old, it only puts out about 25 volts at up to 3 amps reliably. But for everything I do, I don't think I would ever really go above like 15 volts. And then up here is my tiny little Simpson frequency counter, which I've got an extra oscilloscope probe on. And that's what I check my frequency counts. So as an example, when I work on an Intellivision, one of the things I do is I will use my frequency counter and attach to ground and then attach it to pin 10 off the cartridge port side, which is over here, if I remember correctly. And I do that because I want to make sure that I have the proper clock signal all the way over to the cartridge port. If I do, then I know that it's good everywhere else. So, and the service guide tells you to either check it from pin 10 off the cartridge port or directly off of pin 15. But yeah, my opinion is if it's good all the way to the cartridge port, it's obviously working on pin 15. So, all right. But having said that, I'm going to go get my meter and I'm going to verify that pin 10 from here matches up with something else along here because I'm pretty sure it does. Failing that, then I'll just measure it off of pin 15 from here and try to find it. I don't really want to take this whole bottom shield back off just to try to trace it manually, but I know that there is one. I know that there is a via over here somewhere. In fact, I see some solder that I probably put down here when I was working on this board and servicing it. So I'll be right back. Gotta Gotta go get my meter. So hang 10 and pause. Okay. Yes. Well, this particular frequency counter can't show me that last 4 digit. So as long as I've got the 35795, I call it good. Because, yeah, this frequency counter only goes to so many digits. Anyway, now I got my meter. I can verify if I'm correct about that alternate pad for me to solder onto for my clock signal. Because again, Yannick's board doesn't require that clock signal because, as I believe you even stated, it generates its own. So, okay. All right, pin 10, here's 1, 2, 3, 4, 5, 6. Actually, that's right, they go the other way around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is actually, darn it. Is that actually where 10 is? It might just be the case. Yeah, I think that's right, because that's 2, 3, 6, 7, 8, 9. This is 10 right here. So that's going to be a little trickier to attach to. Let's see. Okay, so it's that pin right there. Ready? 2, 3, 4, 5, 6, 10. So should be able to just go from right here. Yeah, there's other stuff in the way, so I didn't think that was gonna. So of course I'm wrong. I'm not getting anything. That is definitely 10, right? 2, 6, should be 10 right there. Okay, actually, what I can do is there's actually a pad right here that's not being used, coming directly off of pin 10. So I guess I could just run my clock signal right from here to there. That's assuming I'm correct, and that is 10. I'm pretty sure that is 10 though, because this is 2, 4, 6, 8. That should be 10. Yeah. Okay. So yeah, there is actually a pad right here directly attached off of pin 10, which should be my clock signal. That'll work. What else we got? RGB, howdy. Oh, we got different people now. Okay, howdy, how's it going? Okay, RGB alone doesn't need a clock. Composite needs it for the chroma subcarrier, and the S-video needs it for chroma. That makes sense. Thought RGB uses composite feed for syncing. Well, sync on composite video and composite C-sync are two different things. Oh, yes, they are. I had to do some reading up on that quite some time ago. It's confusing the way they are named. No kidding. It is. And in the case of the Genesis wiring, and in fact, most of the consoles with RGB, as I'm sure most people have probably started to realize, they're wired up using C-Sync. Not composite sync, but C-Sync. So, except in the case of the HD Retrovision cables. Because HD Retrovision cables actually use the composite sync to do their thing. I don't know why, but they do. That's why I had to do quite a bit of work on a 32X that I added S-Video to make it also work with HD Retrovision cables, because by default, in order to make the 32X S-Video circuit work, you have to disable the composite because it causes interference and backfeeds into it's the chroma. It's the chroma line that backfeeds into it and causes these horrible fuzzy video on the S-Video when you install it. So you have to completely kill the composite. But of course, if you do that, then HD Retrovision cables don't work. So what I actually had to do was, I believe I had to add a cap and a resistor, and I had to filter the sync off of the C-Sync to make it compatible, or I had to do something to it off the C-Sync to make it compatible with the composite. It was either that or, no, I know what I did. Now I remember. I actually added the cap and the resistor, and I had it feeding off of the composite output on the Genesis side, because that is still attached and is part of what provides that's what provides the initial composite into the amplifier of the 32X and then spits it back out again when it reprocesses it. So I was just using the composite input off the 32X to generate the sync we needed for the 30 or for the S-Video and for the HD Retrovision cables to work, and it actually did work just fine. So that was what I had to do. It was I couldn't use it by itself. I had to do something to it to attenuate it and make some changes to it. But anyway, we are at a point. I need to get this clock signal in. So let's just find some wire here. I got a piece of black that's just sitting here. Will work fine for this purpose. And just attach it off that. So I should just be able to attach it off that empty pad and run it up to there. Okay. Strip this out. I'm going to change the angle of my web camera back a little bit. So let me go back like that. There we go. Let's see. Assumption based off of the videos I've seen. I haven't done any actual modding myself. Is there any trickery to get the Hyperkin HDMI converter to work? I have a completely messed up sync, and I want to learn how to fix it. When you say you have a completely messed up sync, describe that a little bit better. Because if you're just using the sync like from the output pad or from the output pin off of whatever console we're talking about here, then you can just use, you can just trace it somewhere else, further up, and just pull it from there. Unless the sync itself is not physically compatible. So what we're talking about. And again, I apologize. I can't really see the chat very easily through my laptop here that I use for capturing. So I will look here in a second after I get this new clock wire soldered on. Okay. I love that there's an unused pad for this. Actually, it's not a pad. It is, in fact, a... oh, man, just dropped my wire. It's a VIA. But... all right, that's in place. We'll just route this up to here. I'll just go ahead and attach it to the pad. And 1 inch of wire is a little too short for me to do any good with, so I will go ahead and trash that. And I don't have to attach this to the pad. I could just attach it to this via here, obviously. From just straight up underneath it. Maybe I'll still do that. Okay, let's get this tinned up. Go. Actually, I shouldn't have done that yet. Nope. Because I was gonna put the wire through there from up underneath. Still a tiny bit left. Not very impressed with this braid. I got it cheap from a place in California where I also got a bunch of panel mount jacks. Specifically, they were one of the few places that provided 8-pin panel mount jacks, similar to the 9-pin like I have here. They also had some 9-pin panel jacks, which looked really high quality. Unfortunately, those 9-pin panel jacks won't work. They are a slightly tinier diameter. There's a lot of flux that came off of that. They are slightly smaller diameter than the actual 9-pin plug. So they will not work. There we go. I got it. That's super nasty, so let me get that cleaned up. Yeah, that first bit of braid I used a different braid the second time, stuff I've already had on hand for a while. That first braid I used, it doesn't really wick up for anything. So what I did was I actually took it, a big chunk of it, and just dipped it into my liquid flux, and just set it out to dry. And that's why it produces so much flux residue. It's all right though. All right, well, this will be a little trickier, but I think I can get it. All right, let's use the other tweezers, which have a flatter base on them, or they have, I should say, more of a surface to grip with. Okay, should be around here. There it is. All right, that's probably not going to stay, but we'll try it. Okay, now grab it, push it through. There we go. Clock signal in place. Got more wire than I need here, but that's okay for now. We'll just get it tucked out of the way. What else we got? I think it's on the Genesis, of course. Yeah, Genesis, of course. I think it's sync. I'm using a Model 1. I can tell that the signal is coming through, but the picture moves down the screen. Oh, you're the one that emailed me. Okay. So I have a set of the Hyperkin HDMI conversion cables, and I've used it with my Model 1, and it actually looked okay. It was nowhere near the quality of the output you get with a set of HD Retrovision cables using component, which I know is strange since it's HDMI, but it was a noisier signal and very dark. So the findings that I had when using that cable mimic the reviews I've seen on YouTube. However, the image did not go all over the place. It was a stable image. So I'm not sure why that would be happening. It's also curious if you get the same results. Have you tried it through your 32X yet? Because you've got the 32X and the Sega CD also attached, if I remember correctly. Okay, yeah. Should have called you. I'm terrible at emails. Well, you could have called me. The reality is although I do have a business Google Voice number I have set up, I don't normally answer it. Not because I'm being a jerk, but because here's going to come a shock to a lot of you. Maybe not. I do not own a personal mobile cell phone. No, I don't. I don't actually own a mobile cell phone. But that doesn't mean I don't have a cell phone, because I do. It's just company provided. So the Google Voice number, of course, comes through that phone. And most of the time when it rings or I'm answering it, I don't want to answer it and talk about this stuff while I'm at work. Not that it's a conflict of interest or anything. I do a large part of the same kind of some component level repair stuff at work, although not near as much as we did, several years back. Everything's tablet based now, so it either works or it doesn't for the most part. But it's just not very cool for me to be, talking this stuff when I'm on the clock at work. So, having said that, most of the time I don't answer, and I just have them go to my voicemail, and then I'll either send a text from there, or call them from there, or start an email chain from there, or whatever's required. Okay, I think we're ready to at least test composite. So, I have to pull it back out because I was trying to view it on the wrong input. Wait, wobbly image sounds like sync or how the thing is handling the sync signal. Yeah, again, I can tell you this. Mike Che will be one of the first to tell you that the Sega systems, first of all, Sega systems, if you didn't know this, they actually utilize TTL sync, if I'm not mistaken, which is one of the reasons why we weren't using RGB from the get-go out of the Sega consoles, was because that signal is there's too much voltage on it for consumer grade electronics usually. That's why a lot of the stuff now uses the composite video to provide C-sync off of it. Or it changes it. Anyway, yeah, if I'm not mistaken, the Sega systems provide TTL level logic for the sync signal, which would overdrive a lot of stuff. In my understanding of that. Get this out of the way. Okay. So anyway, I don't know. It could be how they're handling the sync. It could just be that your TV just isn't able to handshake properly onto the HDMI signal that it's kicking out. Did you try it on different TVs? Were you getting the same results on different televisions? That would be one easy way to check that. Just in case it's not some weird, goofy thing specific to the television that you were using it with. As Crayon King in this very chat will tell you, even these RGB boards on the Intellivision and the results you get can be very TV dependent. Here's a recent example, and this is from my own experience, but also from one of my clients that Now, my client has Yannick's board. He doesn't have Crayon Kings, but similar results. He's got a Vizio, I believe a Vizio 4K TV. And through his Tink 5X, there's only a couple of modes that really give him a stable signal. And even then, when he switches out games, even through the LTO cartridge or a physical cartridge, the image might be slightly skewed or messed up in some way, and he found that he has to hit the reset button on the console, and it will fix itself. And so in that particular case, it's just how the TV is trying to lock onto that sync signal or the lack of it. And somehow hitting reset on the console seems to fix it or help it figure things out. Now, I say that because it's also possible for the same thing to be happening with other consoles, using those Hyperkin cables or whatever solution might be in place. Another solution, although it's kind of an expensive option, would be to try going through try setting up like a triple bypass on the Genesis, because that's basically generating its own unique sync from the RGB and other inputs off the VDP to it. But I've actually not installed a triple bypass. I've never been asked to, probably because there's plenty of other techs out there that offer that service. I tend to mainly stay with the pre-16-bit era of stuff, but it certainly looks like something I'd be capable of doing. It doesn't look impossible or by any shape of the imagination. I was able to install a DC digital without too much trouble in my own personal Dreamcast. So I figure if I can do that, I can probably just about do anything else. Right. Let's see what we get. Let's go ahead and try putting this back together just enough to see what I get on my screens. And again, this is only going to be checking just the composite side of things. I'm not really concerned with much of anything else. Okay. So there's the new wire outputs. Just match green to green. Everything else should follow in sync. Go. Just set that off for a second. And get this plugged in. That in. Sure that's not touching anything it should not be. Let me get my cables routed over here. Okay. And a 201 test cartridge is enough to verify image, since it just fires right up. I don't know if you guys can see it or not in the view, but I've also made a couple of slight modifications to my power supply board. You'll notice it has no heat sinks on it. And that's because I'm actually using a set of Traco DC to DC switchers. I've got a 2450 mounted over here for the +5, and then I've got their, what is this, the 2412 for the 12-volt line. And yes, it works quite well. So the only heat that's really put off by this console at this point, of course, I recapped it, which again, you guys would recognize this from the original tech video I did on this. Again, replace the original ribbon cable assembly with a JST 5-pin connection, so it's keyed and much better connection. So the only thing that generates heat is the transformer will still generate some heat, and obviously those stupid 3906s to the CPU. Nice little heat generators. Okay. Make sure we're in the off position. Okay, we have AC power. I'm going to turn on my PVM, which you guys won't be able to see in the display here. Maybe I can turn this around. I know what I'll do. Hold on a second. Let me get my meter out of the way and some other stuff out of the way. I will lift my laptop and move it. Okay, there's my PVM right here. Is the composite connected? That would make a difference. Okay, got to disconnect my S video. This PVM, if it detects a cable just plugged off of the S video port, even though it's not connected on the other end, which is it right here, it's enough resistance to think that S video is connected, and hence it will try to fire up under S video. So that's not what I want. I'm going to get here's again. This is Crayon King's version 5 board. Put it in here with my anti-static bag with some other version 5 boards I've got. Okay. Turn the iron off for a second and switch it on video. Okay. So we have composite, but that's a pretty glitchy screen. Failure at test. Oh, I know why. Well, no, it shouldn't be fail. Oh, yes, I do know why it fails. Yeah. So I don't know if you can see that, Kevin. But what's interesting is you've got the same sync curl going on at the top that we get on a lot of the other scalers with Yannick's board, but it's usually above the scan line area. So it's not normally an invisible part. Let me just try to reset. Nope. So yeah, that sync signal off of this board is still not quite 100%. Now the reason why I'm getting failures, by the way, at L, M, I think it fails in one other spot, just those 2 points. Okay, so the reason why it says those have failed is because this is actually a Sears Intellivision. So this being the, it does say version 3, but it's actually 1.3. It's not designed to detect the Sears chipset. So it has problems with that. Output looks fantastic using the RF out on the Model 1 through CRT. You know, it does. And in fact, I'll tell you here, Chrono Tango, I believe your name was Jerry or Jerome. The only reason I even started to do AV modifications or AV upgrades on any of my consoles, it was actually the Genesis that was first. And the reason why I did it was because I had my flat panel, like a 40-inch flat panel 1080 display I was using in the game room at the time, which worked great for my, for the Wii that I had connected and my PlayStation 3. But when I went to connect the Genesis up to it, and of course the only output option I had initially was composite, and I had the RF as well. The RF was really fuzzy, nasty, didn't like it. When I attached the composite, I had a good clean image, but that's when I found out the text was almost completely unreadable on RPGs. And specifically, the game I was testing was Shadowrun. So, yeah, that's what we get. Make sure. Doesn't look good. Oh, you're talking about something else. Hey, Kevin, I don't know if you can see this, but if you take a look at the upper display for the PVM, you'll see that the whole top is, woo! Also, the colors are pretty washed out looking. I wonder if that's because of the 75 ohm resistors that are still attached. No, that wouldn't matter. That's only for the RGB, and we're not even utilizing RGB output. I guess I could see what this does on S-Video. I'll need to connect up a couple of wires real quick for my chrominance and luminance on that and see what I get. But yeah, the image is really kind of washed out looking on my PVM here compared to what I'm used to seeing. The greens look okay. But this lavender here, and this should be red, and that actually looks purple. The timer should be a bright red. That is purple. No doubt about it. Totally purple. There's a lot of bleeding too. So like in between this black and the dark blue here, which is the same dark blue as the border, there's a section of red coming through off in this white here. I've got a section of what looks like some light purple or pink bleeding off to the right and also to the left of the black. Between the dark green and the light green, I've got a blue section of blue showing up here. I've got this white between the light green and the yellow, and then between the white and the yellow, I've got a light green. So basically, yeah, the colors are bleeding over, and up here on the keypad section, we've got this light green. It should be a darker green than that. It almost blends into the gray in the background. So yeah, this composite is actually the older composites look a little bit better, to be honest. But again, this was a test. What have we got? The sync issue is from his kit. It's the V-sync area that that he has super weird, or whiter? I can't really tell. The chat window's too far away from me here. 3 times what it is supposed to be. You know it's V-sync because it's at the start of the video. Yes, correct. If you have an O-scope, I'm pretty sure a few of his colors clip. I've never had one to confirm. Yes, we do. I don't know if I'll make this be able to reach because I've got my capture device in the way here. But if I turn my laptop a little bit more further around, you will see my old BK Precision 17 or 1474. It's only a 30 megahertz scope. It's only 2-channel, but it's perfect for old retro consoles, and it works fine, or it works good now. When I first got it, it was dead. I ended up having to replace a cap on the vertical trace line that was sheared off because the way you adjust the rotation on this, there isn't a there's not an adjustment trimmer that's accessible on the back or the front for the rotation. You physically loosen the screws on the back and turn the entire CRT, the actual tube itself, to adjust for the linearity. There is an adjustment here for the astigmatism, but that's it. And then, of course, you have your standard focus and intensity. But yes, I do have this as a scope. And it's pretty good when I need it and when I use it. Where are we at? We're back over here. Okay. What do we got here? Okay, I have a... Oh, can you get the peak-to-peak of the video? Yes, I'm sure I can. I have a monitor. Okay, so now we're back to 2 different subjects. Okay, well, let's see what we can get here. Let me get the probes out of the way. And we'll turn it on. Take a little while for it to heat up. Are you just needing the peak-to-peak off the composite output line? Is that what you're wanting me to check? Because if that's the case, I can just clip off of the center here, which is my video out. I'm not getting anything on the scope. It may be unplugged. Hold on. I'm going to go around to the other side here and check. You guys will get to check out my stylish Atari bottoms here. Oh yeah, it looks like I've got the scope unplugged. Yep. Okay. I think I was needing the outlet for something else, so I had the scope turned off. It's funny, when I first turned it on, I heard it click and pop, That was probably just residual on the caps. Okay. So I'll turn this back on, take a little while to warm up. Yep, graticle is now lighting up, so for sure I've got power to it now. I can get the probe attached to the calibration. Uh, 2.5. There. There's my trace, and there we go. Okay, so peak to peak, what are we looking at? Okay, they should be RGB inputs, preferably. Oh, you want the RGB input side. Okay. Let me see if I can do that. Because, of course, the real trick here is I got to flip it all around so I can access it. Okay. So you want me to scope it out on the RGB inputs, which we can just barely make out. I'll try adjusting this around a little bit like that over here. Nope, it's still cut off. Why is that cut off? Oh, I know why it's cut off, because it needs to be further in the video. Let's go back. There we go. Now you'll be able to see me. All right, first things first. Am I getting my... Let's see, there's that. Yep. Just doing a quick cal, make sure the scope is reading. Scope is good at 0.5 volt peak to peak. It's currently set for 0.5 volts. What are we looking for? What do you want me to set it to? You want me to set it to 1 volt per mark? Let's take the end of the probe cap off here. Need to attach to ground. I don't remember if that's actually tied. I don't think that's actually tied to ground. Let's see. Let me see if I can get it to. Oh, I know what I can do. Yeah, this will work. The RF shield is, of course, tied to ground, so that'll work. But it's way over there. Darn it. Can't win. All right, let's. Might be able to do it like this. That reach? Nope. Nothing is simple. I don't really want to solder a ground wire off of this thing. All right, let me try and find a point close to those where I can get the probe. Here we go. All right, probe's got a ground now, so we can. This will just reach. We're powered on, and let's check the red. Okay, so that's pretty broken up. All right, let me see if I can. All right, we've got quite a lot going on there. Okay. And it is kind of everywhere. There's a couple different signals coming in, it looks like. Increase the intensity. All right, so what I'll do is I will rotate this back over to my scope so that you can take a look at it, okay? And you'll see what I'm getting. Should be reading about 700 millivolts peak to peak where they go into the kit. I would wager it will be higher than that. Composite S video will follow that RGB input, so too high in RGB is too high a composite. Duh, I missed it. I'll have to rewatch this later. Oh, okay, you were trying to, yeah, well, oh, hey, I just got a black and white image through composite. That's interesting. Why is that happening? Yeah, now I've got a black and white image on the composite. But it's stable. Oh, nope, not now. It was. Why am I not getting any color? Is it because, well, no, it's can't, the probe is only attached to ground. It's not attached to anything else. I lost my color that I had. That didn't do anything to the RGB board, did it? But you know what? This is why I still leave RF intact. Okay, we've got color on the RF. You guys can probably barely see it in the background there. Let me move this up a little bit. Okay. Basically, the only thing that can cause black and white. What? Oh, black and white will happen if you lose the clock. Oh. Well, hopefully we didn't lose the clock. Well, we couldn't have because the console's operating. So it's got to be working. All right, let's. I'm going to have to plug that in. Okay. I don't have power on my. This thing's going to be hooked up like it's on life support when we're done with this. All right, where's the. Okie doke. Now we will turn on my freak counter. Attach to ground again. There. And so that stays put. Let's attach it to. Oh, it's all over the place. It's only showing about 2.2. Let's see what we're getting from pin 15 directly. Okay. All right. Okay, 9, 18, 17, 16, 15. $35795, and it sometimes fluctuates down to 4, but it's pretty close. So the clock, well, I just killed it there because I ordered something I shouldn't have. So the clock, funny how this screen looks good in black and white, but once we get over to the controller screen, syncs off. Okay, so clock is good. pen is not. That's why I don't like to attach off the controller port pins. So for some reason, the clock signal at the cartridge port is reading less than it should be. Let's see what I can do. Just double check that. That's reading about 2.2, 2.3 at the cartridge port. So maybe that's not the best place to grab my clock signal is off of pin 10. Although technically it should still be reading the right values with the test cartridge in place. That's what the service manual specifies. Let's check a few things. Let's carefully flip this back around. Okay. All right, I'm going to get my scope off of here for a second. We're going to check the clock again. Hey, I have color again. That's weird. It's not very good color, but I have color. This probe does not want to stay attached. All right. 2, 4, 6, 8, and 10. Oh. 2, 4, 6, 8, 10. Well, that's even less. It's only showing like, what, 1.1 now. That doesn't seem right. Is that the right pin? Yes, because it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I don't know. The readings are all over the place on the clock, at least off of the cartridge port. So let's try attaching that clock off of a, well, I could just solder it directly off of 15, I guess, for now. So we'll do that. Let me get disconnected a little bit here so I've got some room. All right, let's unplug it. So we're going to attempt, just going to run the clock line somewhere else. So let's go ahead and get this freed up. And temporarily disconnect my composite. There we go. Set this out of the way. Okay. Here I was trying to be fancy and slick. Turn my iron back on. I'm going to need a longer wire. I got laying around here. More purple wire. Why not? Sure. Yeah, that'll reach. Really thought there was another spot. Hold a moment. this is why somebody such as myself has spare parts boards. Not only to use for parts, but also so I can look at traces a little bit better. Okay. All right, so there's 18, 17, 16, there's 15 right there. Okay, got a nice big fat trace here, goes to here, it's tied to all three of these, goes to here. All right, it is. So sync can actually be gotten from any of the bottom of any of these diodes, by the way, because those are directly attached to pin 15. All four of them are. Any of the bottoms of these diodes. I'm just dipping. I'm dipping out. Thank you for your advice. Oh yeah, and hey, no problem. And we can catch up more in email once you've pulled your Genesis back out and checked out a few other things, and we'll see if we can figure something out. But are those diodes? Those might be. You know what? Those are not diodes. No, they're not. They are encapsulated SMD capacitors. They're actually caps. So I do know, like I said, that the signal goes somewhere else in addition to pin 10 off the bottom over here. So right there. This has the same unused pad, but we didn't get anything off of that. So yeah, so what I can do is I can just actually solder my wire to the bottom of any of these diodes, because as long as the board is the same, well, heck, I can just check that. That's what a meter is for. Here it is. My stuff is not in its usual place because I moved it all around for streaming. All right, let's see if I'm right about the bottoms of each of these caps coming off of pin 15. 18, 17, 16, 15. Nope. Wait, I am in continuity, right? Yes. 18, 17, 16, 15. Am I getting anything? That's pretty strange. Well, it definitely meshes up on the bottom of this other board from pin 15. I mean, I can prove that right here. Here's 18, 17, 16, 15. What? Oh, never mind. Nope, I'm looking at it wrong. I was one pin off. Huh. Okay, 18, 17, 16. Here's 15. Goes over, goes to here. So there's an unused pad that sits under the sound chip. Well, that's not very convenient, is it? But I know I have traced that to other parts on the board before. I know I have. But it might be something where it doesn't have a direct connection without the system being on because something else needs to switch it. Oh! Okay. R4. R4 is on the other end of that, which is right here. Okay. Here we go. There's a direct connection to the clock off of R4. Okay, so I will just solder a wire to that. I really don't want to solder it to the IC chip if I can prevent it. The heat can cause damage internally, and so anytime I can get away with just soldering to an unused component or via somewhere else in the system, I am all for that. All right, so first things first, let's get rid of this clock wire that I already put in. Doesn't work the way we want it to anyway, so let's just disconnect it. Okay. And let's strip off this. I think for the purposes of this, I will just solder it off the pad. Okay. Goodness. Normally I would use my fume extractor, but then you wouldn't hear me. All right. And this just needs to route, for now, to the leg of that resistor right down there. So if I were to do a permanent install of this wire, although I probably won't anyway because the sync, as we've already established, produces funky results. Okay. We get this clock signal thing straightened out, and then we'll take a look at the readings, or we'll try to do some readings off the RGB lines. This will be a little trickier to solder to. There's a lot of stuff in the way. Okay. There's actually a little too much there. Let's trim a little bit of that off. And okay, there's some solder. Got it. Okay. This will just be to see if this improves that in any way, shape. Maybe the colors will be improved from this. Now that we should have a definite steady clock. What do you think, Kevin? I've been away from keyboard. What's going on now? Okay, so I found an alternate point to attach clock to because when I was measuring it from pin 10, it was basically all over the place. I wasn't getting a steady signal. So what I did was using a parts board that I've got a lot of parts stripped off of, and more importantly, it doesn't have any shielding on it anymore. I was able to isolate another pad that I could easily solder to from pin 15, the clock signal, off the color IC chip to right here on the, well, it's going to be the left to you guys, but technically it's the right leg of resistor 4 here, which is, what is this? Is this the stick, I think, where the stick goes at U2? And that's directly tied to pin 15. So that's what I've done for right now for my clock signal. So I'm going to get this connected back up, and we'll see if we have, and then we'll see what it looks like, and then we'll see what kind of results we have. And this is about to power itself off. That's fine. Get my strap pulled off for a second there. Okay. Now we'll see what kind of results we get. The output. Okay, it's in. I'm going to flip this back over so that we can access the RGB lines if we need to. And get the cartridge plugged in. Goes in upside down when the board's right side up. Audio, video. Composite anyway. All right, let's plug it in. The power off position. Okay. Let's see what we get. Well, we have much brighter colors. In fact, that coloring looks a lot better. We're still skewed on the vertical sync. That's really too bad because that basically looks almost exactly like what his RGB output looks like. I mean, obviously it's composite, so we can see the artifacting and such that takes place in it. And I can't tell if these are vertical bars in the image or not. I only see it in the greens and then the light blues and a little bit in the brown and the lavender here. Otherwise, the colors are dead on. That looks really good aside from the sync. It's also shifted. The whole image is shifted slightly to the left, a couple of pixels, maybe about 2 pixels shifted, I'd say. Yeah, if it just wasn't for that sync going on at the top. Otherwise, the colors look a lot better now. It's probably washed out looking on my camera, but all right, let's see what we're getting on the scope. All right, let's find us a good ground. I can attach to safely. All right, so red. Bring up that intensity a little bit. So I guess I'll flip this around, Kevin, so you can see his VSync does that. Yeah, I know, because it starts earlier than it's supposed to. Yes, we've established that, but at least the colors look good. The colors are way better than they were before. If it wasn't for this, this would be probably the best looking composite I've seen from an Intellivision, by far. So let's see if I can flip this around so you can see the scope. Probably not, but we're going to see. Okay. So obviously because of the angle you're viewing it at, it's also going to look a little off kilter. But from what I can see, sorry, it's hard for me to keep it held down. So I have it zeroed. So the bottom, the fall of the signal should be right at the 0 mark. So it looks like the most it comes up to is roughly about 0.7 volts. It's 0.5 on the strongest part, but yeah, about 0.7. That's what we're getting right there. That's on the red. Now, obviously, it would be better if I had pure images to really see this, but I don't. So we're just going to have to live with this. Here's the green. It peaks also at about 0.7, maybe 0.8. Here's the blue, of which there's more of. And that also, according to my gradical, comes up to right about 0.8. So it looks like his RGB outputs are right dead on where they should be. I guess we can check the sync. Which is registering because that's at 1 volt increments. So that sync is right at about 2 volts, maybe just a hair over 2 volts. So I'm going to move this back around to the monitor so we can see the imagery. So it looks like he's got his stuff. It looks like the outputs coming off of the RGB board are right where they need to be. Yeah. So that's a plus. Not that there was much doubt on that, but it's good to at least be able to confirm that. Oh, by the way, my time setting on that was at 20 microseconds. Yeah, 20 microseconds was where I had that sitting. The calibration, where I normally keep it, or pretty close to, gets tested at 0.5 milliseconds and 0.5 volts. Okay, so I guess I can see what this video will look like. Let's disconnect. Okay, it's discharged. So to check S video, I'm going to need ground, and I'm going to need chroma and luminance. So what I will do is disconnect the composite for now, get my S video harness ready to go. Like that. And the ground will come off the same ground I already have now. And then what I'll do is I'll probably just solder on a couple of these standoffs real quick to the chrominance and luminance pads. I think I will use this one though. Don't I have one that's got 2? Yes. All right. Solder this on. This will have some heat to it. So I don't want to hold on to it, obviously. we go. This video is output's wired up. Plug it into the PVM. And see what it looks like. Oh. Plug the Intellivision back in would help. Okay. Yep. Darn. If only that sync. That's a great picture. Really is. I know it's oversaturated on my webcam, so let me reduce the brightness down maybe a little bit. No, it doesn't help. Let's try. Don't want to bring the chroma value down. What about the contrast? Contrast might help a little bit. No. Well, anyway, you get the idea. It's really too bad because it's looking pretty snazzy. Aside from his sync being off. He always thought S-Video looks more or less like component, at least on my TV. Oh, you've always thought S-Video. Well, I suppose, in my opinion, on a CRT, I could see very little difference, I guess, between S-Video and component. However, that's not the same with an LCD and a good transcoder. Because as an example, with like the 2600 RGB kit, for instance, the component output from that, to me, looks almost identical to the RGB output. And the S-Video on the RGB kit for the 2600 is some of the best I've seen. But I can still tell a difference between that and the component. But again, that's on a flat panel. On a CRT, it's probably much less pronounced. It does look like there's some brightness issues. It's got a little bit of a flicker to it, but that could just be because of the V-Sync. And really, it's a damn shame. I mean, there's no bleeding or anything to really speak of here. This looks really good. I mean, this almost looks comparable to the RGB output on a flat panel if it wasn't for the glitching at the top of the image. So that's really too bad. Let's get a controller perhaps plugged off of this really quick. So I'm going to get the controller cables plugged in here. There we go. Again, this is a Sears unit, so it's got the detachable controllers. Now I've got a rebuilt one here that I've got a stickler plugged into. So it's my preferred test controller. All right, let's see here. Let's get this. Excuse me. Probably should have used the other one. This one's always a bear to get plugged in. I don't know why. I think that's enough though. Yeah. Okay, let's see if we have audio. There's no audio. Huh. Why is there no audio? We're attached off the audio line. Oh. Yeah, I know why there's no audio. There's no audio because I don't have it connected. Okay. So I guess I can connect the composite back up real quick. Make sure I have audio. Disconnect my S-Video on the back. Okay. Sync. Does it say stripped with the might work better for what you are doing. It will be missing some sync pulses, but those older TVs won't care. More importantly, the VSync will also be correct. Yeah, my only concern with that is that I don't normally use a CRT. I actually use my Extron for converting my composite NES video, and it converts it and upscales it and spits it back out as a no lag VGA signal. Okay, let's see if I have audio. Still no audio. Why do I not have any audio? We're plugged in. That should be coming off the audio output. From here, the audio input is attached here. I should have audio, yet I have none. Everything's attached, right? Yep, there's that, there's that, there's that. I should have audio. But I do not. Where is my audio output? Okay, meter time. So the only thing he's doing with the audio on his board, Yannick's board, is from the audio input line, which is down here. Oh, I'm not in continuity mode. Okay, so from here to here, that's good. And then from here to here, it might not register anything because he's got it going through this capacitor. And then from the other end of this to here. Right? Oh, nope. There's no audio because I have it on the wrong pin. I attached it to ground, it looks like. Well, that's funny. Before I do anything, let's unplug it. At least that explains why I wasn't getting any audio. Okay. Now, should have audio. Yeah, I hear it buzzing through the TV now when I'm probing it out, so we've definitely got something going on there. Connected. Okay, so let's get some power. So basically, Crayon King, you're suggesting the use of like a sync stripper to pull it out and redo it. Which you can get one, I think there's a kit you can actually buy from Console 5 just for that. Never really bothered with it, but there we go. Yeah. Again, because the differences in the Sears Intellivision, it erroneously thinks there's problems with 2 of the chips when there's not. So that's completely normal for the MTE201 to fail on a Sears unit. You really need to use the, what is it, the 1.4? So that's the one revision just above this, I think it is. It can properly identify a Sears unit and also works with the Intellivision 2 because you'll also get a similar error. You'll get similar errors with the Intellivision 2, except I think on the Intellivision 2 it's 09 and 06 that it barks about. Okay, well, aside from the sync issues, which are not a surprise, it seems to work, but obviously it's not going to be practical without fixing the sync issues to use it with Yannick's board. And what I don't know is what will happen with his new version 2.0, because he told me he's not using the same diode and resistor method on his new version board that I am using, or that he had me use as a hardware fix for these initial boards. He's actually routing the sync signal now through some unused gates on one of the IC chips on the board. Not sure why he didn't just have me try to wire it up that way, unless he's actually using a different... Oh, he is using a different chip. Apparently the original IC chips that he was using for his board, like what I have installed, is not available or whatever. He's having to use a different board or a different set of chips. Specifically this one right here. So, okay. So I guess that's where we're at. Technically, the board does work, just with issues from the vertical sync, which is too bad. But like you said, might be able to use a separate sync stripper to provide the sync that way. What were you saying about doing that? You said something about that. Is sync does that? Because yes, okay. Sync stripped with the might work better. Oh, you're talking about it missing pulses, right? So the only problem with that is it might not still work with the. It might not work on modern displays. That's where the possible issue could be. At least through things like the OSSC, things like that, they don't take kindly to those missing pulses. So we might be back to where we were at with dropouts, is where I guess we're guessing on that. I assume I'll get the same results on this when I connect it up to my Extron, would be my guess. But hey, it was an experiment. Just wanted to wire it in and see, and check it out, see how it works. And I don't know about Fred's RGB board. That was the first version RGB boards that I think were available for the Intellivision. And I think Yannick's and Fred's boards are basically the same, with Fred using all through-hole components. So Fred's board is monstrously larger, or at least those earlier revision Intellivision boards were quite a bit larger than what we have now with the SMD stuff. Anyway, I guess I'm going to go ahead and end the stream here, because I'm going to pretty much have to undo all this and put the old Retro Fixes board back in, I guess, if I want to maintain composite on this. I was just hoping that the S-Video might be kind of neat if it worked, because if it did, then I was going to go ahead and install a permanent S-Video output jack on this thing and wire it up that way. Before I do that, I might go ahead and test it on my AV setup downstairs just to see how it looks. If it works and looks okay that way, then I may go ahead and leave this in place. But we'll see. Anyway, yeah, with that, I'm going to go ahead and pretty much kill the stream at this point, because we've tested what we needed to test. Oh, wait, we've got something else here. Unless he's using a mono-stable and some legit circuitry, there is no way I can see to fix the sync without some programmable IC. I'm only explaining what he told me in an email exchanges or through private messages at Atari Age. I asked him if the hardware fix that I'm using here, which works on the OSSC and on most of the other stuff with, again, some slight skewing on the RetroTink 2X SCART that I have. By the way, I didn't take any pictures of how it looks, but on the RetroTink 5X, Yannick's board actually has the vertical sync in the opposite direction. It's usually at the bottom of the image, not at the top, which is interesting. And through the OSSC, there's virtually none at all. There's just a tiny little bit, like maybe about 8 pixels or so at the very top of the image that aren't displayed, but the rest of it's there and it's stable. However, every time I try to capture video through the OSSC with Yannick's board, the image is constantly flickering. So I have to assume there's something there. I think it's just the capture device doesn't like it, because the OSSC is providing a fine picture, and my TV doesn't seem to have an issue with it either. And other people that have used Yannick's board on the OSSC and on the Tink 5X got the same results I got. So, yeah, I don't know. He's using a different chip to handle the sync, and he said that he's redoing the sync by running it through unused gates that he wasn't using on the original chip, which is true. There's only like 3 or 4 traces coming off of this chip, and I'm not even sure what that is right offhand. I can't see it right offhand. What is that? Let's try to clean it up a little bit. It's got some old, I don't know, probably my fingerprints. It is really small. It's a Texas Instruments chip. The number markings are HT00 along the top, 9 Bravo Kilo, George 4, or Golf 4 on the second row, and ASQE on the bottom. So, yeah, I'd have to look that up. But that's where the sync signal is going to, or at least where it was going to. Now, with the way it's been wired up now using the different inputs off the color chip, I'm now bypassing some of this, and it now routes directly, I believe. You know what? I think this is just tied directly to the sync output on the other end. I don't think it's going through any chips now. I could be wrong on that, but I don't think it is. Okay, so yeah, again, I'm going to go ahead and end the stream at this point. I mean, I've got this wired in. What I will do is, like I stated, I will leave it kind of haphazardly set up like this, and I'll probably check it out on my much larger AV setup in the game room downstairs outside the tower, and see what results I get there. My prediction is I'll have basically the same thing I see on the CRT. That would be my guess. If for some reason it does look good and it's cleaned up, well, then that's great for me for personal use, but it's not something I can recommend for my clients, because obviously they might want to use it on a CRT, or I can't be sure that whatever device they are going to attach it to isn't going to have some weird issues, possibly. So for just to make sure and for standardized reasons, I will not. I will probably not recommend the expansion board in conjunction with Yannick's board, at least this version. I don't know about his new one. I have no idea. But until I can get one of those in hand to check it out and test it, I won't know. But my plan, when I do get Yannick's new boards in from Console 5, or hopefully I'll get some in from Console 5, I will probably just replace it out. I'll just take this board completely out and replace it with one of the new ones. Because the current board, his replacement board, is the exact same size. And everything is in the same place as far as his inputs and outputs go. And they're in the same order. Except now he's got like letters or numbers, I think, next to the vias, so that it's easier to know what goes to what. Anyway, thanks for hanging out this afternoon. And I will see you guys later. And hopefully, Kevin, you've got some new answers now as far as what the readings are from his board on the scope. Again, from what I was taking a look at, it looks like it's pretty much where it needs to be. Most of the individual color lines were putting out what looked like at least 7 volts, but could have been 7.5 to just under 8 volts. Or I'm sorry, 0.8 volts peak to peak. And my phone's going off somewhere, but I don't even know where I put it. Oh, there it is. And then we're registering at what looks like right at 2 volts, just over 2 volts off the sync line. Alrighty, so thanks again, guys. Check you guys later.